So before I touch this up, I have taken the grinder and ground into this area that had the crack. My first pass with the TIG will burn through the base of this to catch the crack as it enters this hole. The objective here is to burn through this so that there's no remnant of that crack anywhere across this face. We'll take care of that at the same time we touch a few of these areas up.
TIG welding creates a smaller heat affected zone, which is very helpful for touching up.
One of the wonderful aspects of TIG is that you can touch up on this level. Any of those surface flems are now taken care of. They can be ground and then finish sanded. I'm going to go ahead and fix this area here now where the crack existed and actually show the welding process.
I am really liking the HTP Invertig 221 arc stability. This is a wonderful machine to weld with.
The footnote to all of this is that the 888 has very high tensile strength, and this slight overlap here in the bore, I tried to hit it with a file and there was no such luck on that note. So I'm using a carbide burr grinding tool to shape this and just basically knock off the high point in the weld. And of course that made quick work of it, but again, realize how hard this is, that it actually takes a carbide tool to cut it. So the strength in this area is absolutely beyond a doubt far better than the original steel casting. A couple of things have gone on since our last work with this project. So as you can see, I ran a series of beads, again TIG with 888. In the process, I decided that it was best to peen each of these weld passes at the end of each bead, and I'm happier with the results. It's crack free again. It was becoming a very large mass of metal. A lot of heat was sinking into it. And in a case like that, especially where the casting is uncertain, and we're talking about properties similar to cast iron in some ways, and behaving in some ways like cast iron, I decided that it was best to peen in each weld pass. Here you see my bidirectional overlapping beads, and you can see the strike marks from where I actually peened each of these beads. I also wrapped the entire piece in a heat blanket following all of the welding. It was exceptionally hot. The heat had dissipated, especially with peening, had dissipated through the entire shank of this handle. And so I wrapped it in my Kevlar welding blanket and allowed it to cool down slowly. And the results look good. I'm going to go ahead and grind this. Well, when I went to the grinding process, this piece was shrinking in size the more I was grinding on it, obviously. Decided to build up the shank in this area and continue to build the backside of it. And I'm now at the point where I have elected to fill each of these holes that existed on the side as well. There are weak areas in the flange. You can always drill new holes, and it just made better sense to start fresh and give the piece integrity and strength. Again, we're using the Weld Mold 888 rod, high chromium and nickel content for welding filler, and so we've increased the tensile in the two areas that were formerly weak. Anyway, let's grind some more, see what we have, and see if we've got a finished product now. Here's some initial grinding. I'm really pleased with the way this is shaping up. The top side view, I'll do some finish grinding on this, and then I'm going to use the belt sander to put a final finish on it.